Hello, this presentation is for submission to the Discover Student Symposium of 2023. My name is Niray Bhakta. I am presenting untargeted analysis of beer classes with quadrupole time of flight mass spectrometry. I work in Dr. Shug's lab here at UT Arlington. According to the Brewers Association, in 2021, there were over $1 billion of gross income from beers, with over 9,000 brewers, and of the 9,000, 21% consisting of microbrewers. Beer consists of four main components. We have water, malt, yeast, and hops. Now, we can mix, mash, and infuse them uniquely. However, the base components remain similar in all cases. And what microbrewers do is enhance or make distinct flavors per beer or per source. For this experiment, I used a quadrupole time of flight mass spectrometer, which has a high resolution for analysis of compounds in varying size and weight. From this, we acquired independent acquisitions or sequential window acquisition of all theoretical mass spectra for exact mass determination. Now, we say exact mass because it is very exact to the fourth decimal place. From this, as it is a very large data packet that is acquired, we used a MS Data Independent Analysis Software, or MS-DIAL, for the deconvolution of all of this data to then put through a principal component analysis for further determination of what we are looking at or what we are seeing from this spectra. For the method, we used a very simple reverse phase column, the Restec Raptor ARC C18 column with mobile phase consisting of water, acetonitrile with 0.1% formic acid in both. The sample prep was very simple for this experiment. We purchased all of the beers, we degassed them for 30 minutes, and then diluted them 1-to-1 with water and injected only 1 microliter in triplicate. The acquisition was in negative mode for all of the samples with a specific swath acquisition of 50 to 1,000 Daltons or M/Z with a collision energy spread of 15 plus or minus volts in both directions for all the precursors, so we get a good distribution or information of all possible products from each of the precursor masses through the TOF, or the time of flight analyzer. From this spectra, we see a couple of different things. The MS-DIAL will give us exact library references. So in the bottom right, you see the top, which is what was measured from the QTOF, and the bottom in red, which is what is measured from a library used to analyze or compare against what was recorded for all of the QTOF data. Now, we use a library because the QTOF will give us hundreds of thousands of data points. So in this specific case, we got over 1,000 unique features for each of the beer components, which trying to do that manually would be unfeasible. And we use the library to differentiate between unknowns, reference knowns, or what is expected from the library. We use principal component analysis after that to then bucket each of the beers to differentiate the types of beers from each other. From the principal analysis, we see wheats are very different from blondes and stouts, and IPAs are different from all three. Now, the principal component analysis was not able to subdivide stouts or blondes from each other. However, in the future, what we could do is post-analyze this or reanalyze with positive mode to see if we can get a little more selectivity from the stouts and the blondes, or any other unique distributions, or purchase more beers or varieties to see if those can give us more precursor masses that are different enough to differentiate the stouts from the blondes. For this experiment, I did want to give special thank you to Dr. Shug for giving me direction on this analysis, and the Shimatsu Center for Advanced Analytical Chemistry for providing the instrumentation. Thank you for allowing me to present for this presentation.